Hello all, welcome to Lab 9. So we have completed to Lab 8 and I have made an announcement that it is due tonight. Okay, so make sure you submit your assignment on time. Okay, so let's get started with Lab 9 and if you have any questions on the previous lab, we can discuss that once I finish Lab 9. Okay. Now, Lab 9 is about series. Now, we have already studied about sequences, right, in Lab 8. Now, what is the difference between these two? Um, so, a sequence will be represented in this way. If I consider an as a sequence, and from n equal to 1 to infinity. This is called as sequence if you represent in this way. And when it is a series, we represent that in this form. Now, what is the difference here? Don't think that the difference is the number, the letter N and I, both are same. Both mean the same thing. Now, what is the difference here? Can anybody tell me? What do you think is the difference between sequence and a series? Okay, let's expand these two. Now, when I write a sequence inside a flower braces, you will expand that in this way. A1, comma A2, because n starts from 1, and so on up to A infinity, right? It's not like this. It goes on till n equal to infinity. So this is a sequence. Now, when it comes to series, how do you expand this? This will be A1 plus Y plus, because we have a summation symbol, A1 plus A2 plus so on up to infinity, right? Now tell me what are the difference between these two? The difference is, in a sequence, we arrange numbers in order, right? So that is called as sequence. When you add those each number, each term in the sequence, if it is added, that becomes a series. Okay, series is nothing but a summation of the sequence. Got it? So that's the main difference. And now today we will study more about the series. Okay, now you have to get ready for the lab 9 because in total you have 25 questions and you have 6 types. There are 6 different type of problems. Altogether you have to solve 25 problems. Okay, it is a very lengthy lab and I would advise you to start maybe from tomorrow. Okay, tomorrow means 31st. Okay, so make sure you start your assignment early so that you can finish it off. You cannot finish lab 9 in one day, and you know that I will not be extending the due date because we are already 1 week behind due to the spring break. I had to postpone the assignment, so we need to finish on time. So I will not be postponing any due date of the future lab. So make sure that you submit lab 9 before the due date. Okay, fine. So let us study about lab 9 today. Now, in the first type, You have a geometric series given. These are the geometric series. You need to find the first term of the geometric series and the ratio R. The first term in the geometric series is A, and you need to find the sum Sn, right? So how do you write the geometric series? You write geometric series in this way: A plus AR plus AR square plus so on. So this is the first term in the geometric series, and R here is called as geometric ratio. Okay, so we need to find what is the first term, geometric ratio, and the total sum of that series. That's your first type. And in second type, you have a same geometric series, but you need to find the constant R. Here, as you can see, the constants are given, right? All you had to do was you need to find the sum. So here it is a reverse case. You have a sum given, Sn is given, you need to find the constant. Okay, so that is second type. Now, in the third type, you need to find the sum of a rational value. So when they represent something like this, 0.3 to the bar, that means that number, that particular number will be recurring. Okay. For example, if I have 0.13 to the bar, that means the number is written in this way. It never stops. Okay. But if I have a bar only on 3, then your value will be expanded in this way. Okay. So if you have 1, 3, so there is a bar only on one term, then this is how you will expand. Equal to 0.13333. So the bar represents that a number is recurring. It will not stop. Okay, fine. Now we need to write this type of value, a rational value, in terms of geometric series and find the sum or the Sn. Okay, that's type 3. In type 4, you need to prove that these series are divergent according to divergence test. And you need to tell why is that diverging. So when they ask you the reason why is it diverging, that means you can write a definition or a theorem related to divergent test, and you can just refer it. So by taking a reference of the divergence test, or according to divergence test, or according to the definition of divergence test, so and so sequence is diverging. Okay. Now remember, when they say it is divergent, that doesn't mean that these sequences has to diverge. It may converge or it may diverge. Okay, you need to find out that. Now in type 5, you need to find the sum of the following telescopic series. Now what is this telescoping series? Now in this type of a series, the first and the last term are the only terms that remain when expanded. Okay, for example, let me take 1 plus 1 minus 1 plus 2. Let us consider this series. Okay, n equal to 1 to 4 something. Okay, now this, when you expand, that means you just need to start from n equal to 1 and keep on plugging in the value for n and then expand. So that will give you half minus 1 over 3, right? This is one block. This is for n equal to 1, right? Now, for n equal to 2, you get 1 over 3 minus 1 over 4. Now, for n equal to 3, you get 1 over 4 minus 1 over 5. Right? Let us stop till 3. We can expand, but let us make it short. Now, you can clearly see that the negative 1 over 3, positive 1 over 3, negative 1 by 4, positive 1 by 4, right? It get cancelled. The only term remaining is the first and the last term. So this kind of series is called as telescoping series. Okay. Now, in the type 5, they are not asking you to prove that whether this is a telescoping series or not, because all the problems from 17 to 19, all these 3 problems belong to telescoping series. They have already told you that it is a telescoping series. Your work is to find Sn. What is the sum of that series? Sometimes the sum of the telescoping series will be equal to infinity. So at that time, you can write the conclusion saying the sum does not exist. Okay, this is type 5. Now, the last type is 6. Now, you need to find out whether the following series given will that follow the integral test. In other words, can you apply integral test for all the series given here? That is the question. Okay, check whether you can apply integral test can be applied. Okay, that is type 6. If so, then you need to prove whether it is diverging or converging or diverging. Okay. Now, about integral test. You might have studied this in your lecture notes, but still. Now, whenever you want to apply a integral test, you have 3 conditions. A series, if you write that in terms of a function, then it has to be positive. The function has to be continuous. And any idea what is the third condition? It has to be positive, continuous, and decreasing. Okay, so these 3 conditions has to be satisfied in order to apply the integral test. Okay, we will study more about this. Now that's your lab 9. You can see that there is a lot of work to do. Okay, it is not just that you write a value. No, you have to explain in detail. You have to mention all the steps involved in that problem. So it is going to take a lot of time. So make sure that you start your assignment early. Okay. Now, I will explain you, or I will give you examples for each type, and we will see how it works. If you have any questions till now, let me know in the chat box. Or if you want me to explain anything, let me know. Okay. Now, the first example for the first type, you need to find the first term and the geometric ratio R and Sn, or geometric series. That's the first type, right? Okay, remember these are just an examples. Got it? Now, let me take an example of a series n equal to 0 to infinity for negative 2 to the 2 raised to n and 5 to n plus 1. Okay, now let us start expanding the series for n equal to 0. What is the answer? We get, let me see the first term, equal to 1 divided by 5, right? Why is it 1 here? Negative 2 raised to the power of 0 is 1. Okay. Now this is equal to a. That is your first term, because I told you in the geometric series, how does the series look like? A plus AR, A plus AR square, plus so on. So this is the first term, right? So that is A. Now for n equal to 1, the second term, n equal to 1, the second term will be equal to, just plug in n equal to 1 in the series. So you get negative 2 raised to the power of 1 divided by 5 cube. So that will give you negative 2 divided by 5 cube. And this is equal to the second term, AR. Okay, this is the second term. Now, the question is, you need to find the first term. We did that. And then you need to find the geometric ratio that is given by R equal to AR divided by A. Okay, the second term divided by the first term. So you get negative 2 by 5 cube plus multiply 5 by 1. You get negative 2 pi squared. How can you check whether it is correct or not? Always, when you have R, it will always be less than 1. In a geometric series, the geometric ratio will always be less than 1. Okay. Okay. Now next is, you need to find the sum of a geometric series Sn will be equal to A divided by 1 minus R. This is the formula for the summation of a geometric series. Okay. So A is what? 1 over 5 divided by 1 minus R is negative 2 divided by 5 square. This will be equal to 5 divided by 27. You can do this in your calculator and check whether it is correct or not. So when you do this, you have to get answer as 5 divided by 27. There you go. That's the first type. The first term, geometric ratio R, and the summation Sn. Okay, this is how you have to do the example 1. Okay, I hope you have taken down. Now let us move on to example number 2. Type 2, we need to find a constant. Sum is given, we need to find a constant, right? So let me take example as n equal to 0 to infinity, r to the power of n equal to 23. Okay, now you will follow the same steps as we did in the previous problem. For n equal to 1, we get a, the first term, that is r equal to n equal to 0. So r to the power of 0 is 1. Now for n equal to 1, we get a second term ar, that will be equal to r, because r to the power of 1 gives you r. Okay, now we need to find a sum Sn. Sorry, we need to find a constant. The sum is given. The sum is 23, right? Now, what is the formula for a summation of a geometric series? A divided by 1 minus r, that is equal to 23. Now, we know that a is 1. 1 divided by 1 minus r equal to 23. Now, you can find r here, right? So, let me write it here. So 1 equal to 23 times 1 minus r, that is equal to 23 minus 23r. Okay, now when you find or equate for r will be equal to 22 by 23. If you want me to explain in much more detail, let me know. So r is a constant of a series that is equal to 22 by 23. Example number 3. You have a rational value. Let us take it as 0.13 and let me put bar on both the numbers. Okay. And let us expand this and write in a form of geometric series. And then we will find the sum or a final value of a rational value given. Okay. Now, in order to expand this, remember, if you remove the bar, then you have to write a number in this form, right? It keeps on repeating and so on. Now, if you want to divide this or write as a sum, then let me start writing it as a group of two numbers. So you get 0.13 plus 0.0013. Why two zeros here? Because I have taken out 13 here, right? So if you cancel out 13 in this group, you will replace that with a 0. So you get the second term 0013 plus. Now I have written this 13 as well. So you get a third term. You get a third term as 0.1234. 4 zeros and 13 plus so on. You need to at least write 3 numbers for a series, okay, for geometric series. Any questions on this problem? Do you want me to explain it again? Okay. Now let us write a decimal in a fraction format so that it will be slightly easy to solve. Thus 13, 10,000 plus so on. So the trick part here is, the idea on how to write this as a fraction. If you have two numbers after a decimal, you will divide that by 100, two zeros. Okay. If you have 1, 2, 3, 4, four numbers after a decimal, you will divide by 10,000, four zeros in the denominator, and it goes on. Okay. Now, we know that this is the first term, this is the second term, AR, and this is AR square, right? Okay, so the first term A is equal to 13 by 100, and then the geometric series R is given by AR divided by A, the second term divided by the first term. So the second term here is 13 divided by 10,000, and you have to divide the whole thing by 13 by 100. You can do a reciprocal and then cross multiplication. So 0, 0 cancels. This is 13 here. 13 and 13 cancel out. The left out is 100. So the geometric ratio of this geometric series is 1 by 100. And again, this is less than 1. Now, the sum Sn will be equal to A divided by 1 minus R. Okay, so we know that A is 13 by 100, whole divided by 1 minus 1 by 100. If you do this or solve this in the calculator, you get 13 by 99. So this is how you find the sum of a rational value. Okay, let us move on to example number 4. For the type 4, you need to apply divergent test and check whether the series diverges or not. Let us take example of this, n equal to 1 to infinity, n divided by ln of n. You need to check whether the series diverges or converges. Okay, now you must know about L'Hospital rule, right? I taught you in the previous lab. So we apply L'Hospital rule when we are not able to solve the following series. Okay, now you need to simplify n divided by ln of n. How do you do that? So one thing is you can apply L'Hospital rule. So according to L'Hospital rule, you need to find the derivative of the numerator and the denominator separately, not together. Do not apply quotient rule for this series. Okay? No. I said find the derivative separately for the numerator and the denominator. Okay? Now this is how it works. Summation n equal to 1 to infinity. The derivative of n with respect to variable n will be 1, right? Divided by derivative of ln n is 1 over n. Okay. Now do not bring this to the numerator. Now write or apply limit or apply divergent test. Limit n equal to infinity. The sequence 1 divided by 1 over n will tend to what? I'll give you a hint. Plug in n equal to infinity in the denominator. So this becomes 1 divided by 1 by infinity. Now tell me what is the answer for this sequence or a series. No answer? Okay. Okay, somebody said infinity. Any other answer? I will make it more simple. We know that 1 over infinity is 0, right? So this becomes entirely 0. Then this is 1 divided by 0. So the answer is infinity. Okay, so this is how you have to apply the divergence test. It might not be this too long. You can write the answer directly here. You know that when n tends to infinity, the denominator becomes 0. So anything divided by 0 gives you infinity according to divergence test. Divergent test. Okay. Now, since limit is tending to, or the sequence is tending to infinity, what does that mean? Is it converging or diverging? Good. It is diverging. Okay. See, very simple. That's how you apply divergence test and prove it is diverging. Okay. That is the fourth type. And the fifth type is you have a given telescopic series and you need to find the sum of it, right? Now let me say I have summation n equal to 2 to infinity. And let me take ln. Okay, this is the series given to me and I need to apply, I need to expand the series and find the sum. Okay, now when you plug in n equal to 2, why 2? Because in the problem it is given that we need to start from n equal to 2, right? So we get ln of 2 minus ln of 3. This is for n equal to 2 plus smaller one. Ln of 3 minus ln of 4 plus ln of 4 minus ln of 5. Okay, it keeps on going. Now, what is the last term? You get ln of n minus ln of n plus 1. Okay, now you can see that the middle terms, whichever is there between the first and the last term, will be cancelled. Now this also will get cancelled. Why? Because in the previous term, you will have negative ln of n. So this get cancelled out. So the only two terms which are remaining in a telescopic series is the first term and the last term. Okay, now how do you find the sum? Sum will be equal to limit n tending to infinity of Sn equal to ln of 2, sorry, limit n tending to infinity of ln of 2 minus ln of n plus 1. What do you think is the answer? Oh, great. Yes, the answer is negative infinity. Okay, so what does that mean? That means the sum does not exist. So that's how you solve type 5 problem. And the last type is, okay, I will give you two examples here. Okay, you need to apply integral test. You have to check whether you can apply or not. That's the first step. Now let's say that you have a function given. For example, you have summation n equal to 1 to infinity x square. Let's see. Okay, so when you write this as a function of x, you get f of x equal to x squared, right? Now, what are the three conditions of integral test? It has to be positive, it has to be continuous, and it has to be decreasing. Those are the three conditions to be satisfied. Now tell me, is this function, the function given here, is this positive? Always positive. I'm not asking about the value. I'm asking about the sign of the value. Will this series or a function be positive on the entire interval? For example, if I take x from 0 to 5, okay, I can choose any number from 0 to 5. So if I choose 4, for example, and if I apply to the function, I get 4 square, right? That is positive. Now, if I do this for any number, will it be positive or negative? It is a very simple question. Okay, so how do you test it? Take x equal to 0 first and check whether it is positive or not. Then go with x equal to 1 and then find what happens to the function at x equal to negative 1. Do this and tell me whether the function is positive for these three values. It is positive, right? It is positive. Is it continuous? So when I say continuous, that means there should not be any break or discontinuity in the graph, right? That's how the continuous is defined. Now this is the x-axis. Let's say from 0 to 5, 1, 2, 3, 4, 5. Okay. Now according to the function x square, 1 square is 1, 2 square is 4, 3 is 9. What is happening to the graph here? It is continuous everywhere. Even if you take x equal to 10,000, it will definitely be positive and continuous. There is no point of discontinuity for this function. Okay. Now, the problem here is the function is increasing. Even if I choose -1, it is 1, -2, it is 4, right? You get the same thing and it is increasing. So on either side, no matter what is the quadrant, you get increasing function on both the side, right? So can you apply integral test for this type of function? It is positive, it is continuous, and it is increasing. What do you think? Do we have to apply, or can we apply integral test for f of x equal to x square? You cannot. Okay, why? We want it to be decreasing, not increasing. We don't want a function to be increasing. It has to decrease, and also it has to be positive. Okay. So it doesn't meet the conditions of the integral test. So it is not, it is not satisfying the conditions of integral test. So we cannot apply the test for this function. Okay, so you will come across these problems in your assignment 9. So if you do so, then just write a one-line answer saying we will not be able to apply integral test because of so and so reason. You must also specify the reason. Okay, fine. Now let us see an example where you can apply integral test and how do you solve that. N equal to 1 to infinity. 1 divided by n, 5 by 3. Okay. Now, if I write this as a function of x, you get 1 divided by x to the power of 5 by 3. Now, is this positive for positive x? Yes, it will always be positive. It is definitely continuous. And it is decreasing. Why? Because this is 1 divided by something. So when you're dividing any number by 1, it has to decrease. It will definitely be less than 1, right? Even if you divide by a very large number, this will be nearly equal to 0. So if you are dividing by that number, it will be definitely less than 1. So it is decreasing, it is positive, and it is continuous. We can definitely apply integral test. Now, how do we apply integral test? I told you in the beginning that we integrate the function from 1 to infinity, 1 divided by x to the power of 5 by 3 dx. And we apply limit extending to infinity as well. Now, when you integrate the given function, you get -3 over 2 x to the power of -2 by 3. Oh, this is 5. 5/3. Okay, and apply limits from 1 to infinity, or you can take it as t. This is t to infinity. Remember, we did this in the previous lab, right? So we get limit. Let me change it to t. I will take the constant outside. So all I left out with x to the power of negative 8/3. So this will be t upper limit t minus 8/3 negative 1 to the power of anything is 1. So I'll just write 1. Okay, now I can write this in the other way around. That is negative 5/3 t to the power of negative power. So 1 divided by t to the power of 8/3 negative 1, right? So now when t tending to infinity, when you plug in infinity to the denominator, you get 0. So what is the answer? Answer is 5/3. Okay, that's it. So that's how you apply integral test and find the limit. Remember this we did in the improper integral chapter or a lab. So when you have an improper integral, that is 1 from 1 to infinity, you cannot apply the same limit. So we change infinity to a variable t, and then we apply limit t tending to infinity, right? So that's what we did just now. Okay, so since we are getting a value or a limit, we can say that a series is converging according to integral test. So this will complete lab 9. If you have any questions on lab 8 or lab 9, you can stay. If not, we can meet in the next week. Let me stop the recording.